Oil in my vehicular.
You need some oil.
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 Be strong.
Today we're talking about lipids, folks. I know you're excited. So, two functions of lipids. Number one, long-term energy, like in our fats. Number two, cell membranes and waterproofing our bodies so we do not dissolve. Let's talk about the long-term energy portion first. This is where we get our energy after we've burned all of our glucose. Now, lipids are a little different. They're monomers. They only really have two. They have a triglyceride. I'm writing that in the US of A colors because tri means three. Glyceride refers to the number of fatty acids that it has. If I look at a triglyceride, it is made up of one glycerol, that's the blue, and three fatty acids. If you can remember what the US of A flag looks like, America herself, you can remember the triglyceride. The fatty acid tails are what actually holds the fat. It holds the energy right there. The glycerol is kind of like a paper clip that holds the fatty acid tails together. Membranes are up next, and with our membranes, they have a monomer, and it is called a phospholipid. Kind of looks like a stick figure with no arms. Let's break this down. The phospholipid, phospho, refers to the phosphate. We actually call it the phosphate head, so you can draw a little smiley face on yours as you're following along. The second part is called the fatty acid tail. And if we look at our fatty acid tails, notice one is a straight line, one is a crooked line. The straight line there is saturated, and the second one is unsaturated. We'll talk about that later. If we look at the purpose of these phospholipids, they form the cell membrane, and they line up together as if they were soldiers in an army, and they form a wall against water, and water can come against those and it can bounce off. But here's the problem. It can only protect from the phosphate head side. Remember, we said the phosphate heads are hydrophilic. That means they're tough, they like water, and the tails cannot protect against water. So what do we need to do? We need to put our phospholipids back and forth, kind of like I watch your back, you watch mine.
I'm gonna lean up against you, you just lean right back against me. This way we don't have to sleep with our heads in the mud.
And they form a circle, and that way any water cannot penetrate through the cell membrane. But wait a second, with this model it means I can't have any water on the inside. So what do I need to do? I draw a second layer of phospholipids on the inside. That way water can be on the inside and protected from the outside. So let's recap. I have a phosphate head. It is hydrophilic. That means it is literally water loving.
My little darling, it is love at first sight, is it not? No?
It can protect us from water. It can hold it off. I have a fatty acid tail that is hydrophobic. That means it is afraid of water. It does not mix. It is non-polar, if you remember from our chemistry videos. So we can say that it is water-fearing. Our cell membranes make up a double layer because our cells need water on the inside too. This double layer is called the phospholipid bilayer. Bilayer means two. One layer on the inside, one layer on the outside. Another name, actually several other names. We call this the fluid mosaic model, like mosaic tile. It has a lot of different pieces. We also call this the cell membrane, as I've been saying throughout this video. We call it the plasma membrane as well. So it's got a lot of different names. We do need to know them all. And that is lipids. Remember, long-term energy, that's our fats. And the cell membrane. That is our waterproofing that keeps us from dissolving on the days when it rains. And that is all for lipids, folks.
I'll say, what do I say, Carol?
And that's the end.